Hello guys, welcome to the third lesson of Maths Paper 2. In this lesson we're going to be dealing with compound angles, and for revision lessons please check out our previous videos, lesson 1 and lesson 2. So let's get on right onto it. So with this video, let's look at our compound angles. Compound angles, you need to know that that's when we're subtracting two or more angles. It's addition of two or more angles. Or subtraction of two or more angles. You need to remember that. If you're going to have two or more angles, that's our compound angles. For example, if you have something like cos A plus or minus B, you need to remember that this is not equals to cos A plus cos B. This is very wrong. You need to remember that. And then also, if we have something like sine A plus or minus B, this is not equals to sine A plus sine B. This is also wrong. You need to use compound angle formulas in order for you to solve compound angle problems. The formulas that I used, I'm going to write them down here for you. These formulas are very important in solving compound angle problems. So the first one, we're going to have cos A minus B. It's going to be equals to cos A multiplied by cos B plus sine A multiplied by sine B. And then the second one will be cos A plus B equals to cos A multiplied by cos B minus sine A multiplied by sine B. So you need to remember that for cos, this sign here changes. So if you have a negative on this side, that means when you write your formula, it's going to be a positive. And then if you have a positive, it's going to be a negative. So the sign changes. And then for sine, so that's going to be our third formula involving sine. Sine A plus B equals to sine A multiplied by cos B plus cos A multiplied by sine B. And then the fourth and last one will be sine A minus B equals to sine A multiplied by cos B. And then minus cos A there, sorry. And then multiplied by sine B. So for sine, the sign doesn't change. If it's a positive on the side, you're going to be positive there. If it's a negative, you're going to have a negative there. You need to remember these formulas when solving different compound angle problems. So you guys can pause the video and you can copy these formulas down, because they're going to come in handy in our next examples and problems. So for example, let me give you an example on this side. Example, the first one, let's work with cos A plus 60 degrees plus cos A minus 60 degrees. So with this example, we need to know that you're working with cos. So that means you're going to be using these two formulas here. So we're going to be using the one with the plus and then the other one with the negative. So the one with the plus is this one, cos A plus B. That means you're going to get something like cos A multiplied by cos 60 degrees, because in this case our B is 60 degrees. We're given a value for B, 60 degrees. And then remember that if it's a plus, it's going to be a negative when we're dealing with cos. Minus sine A multiplied by sine B. So we're dealing with this first part. This is the first part right here. So now for this one, for the other part, let me just write it down here, because there's limited space on the side. So it's going to be something like, write it down here. So we're dealing with a negative now. We're subtracting angles. So it's going to be cos. So it's this one here, the first formula, cos A multiplied by cos 60 plus, because it's a negative, it's going to change the sign. It will become a positive now. Plus sine A multiplied by sine B. So now that we have these two expressions, we're going to have to simplify them. Because as you all know, this 60, it's a special angle. So we need to use, sorry, let me just put the value of B, which is 60 degrees here. 60 degrees there. So yeah, because we're given B in this case. So now we're going to have to simplify these two expressions. Let's start with the first one. Let me just write it down here nicely. It's going to be cos A and then multiplied by cos 60. From our previous videos, the revision lessons, we dealt with special angles. So we know that the value of cos 60 is a half. Plus sine, sorry, we're dealing with the first one, which is a negative, that one. Dealing with this one here. So it's minus sine A multiplied by sine 60. From special angles, we know that it's equals to the square root of 3 over 2. And then solving this thing further now, it's going to be, or we can move into the second one, second expression. Let's just try to simplify it, because we also have special angles in that expression. Cos, well, we can name these expressions, okay? This is the first one, expression number 1, and then this expression number 2, so that you guys don't get confused. So we have dealt with expression number 1, so we're moving on to expression number 2. Let's simplify it. Cos A multiplied by cos of 60, that's equals to a half, minus, you know that sine 60 is equals to, so it's going to be sine A multiplied by square root of 3 over 2. So now in this case, we're going to have to simplify this expression further. We're going to do that by adding, this is number 2. We're going to do it by adding expression 1 and expression 2. That's how we're going to simplify this particular problem. It's going to be cos A multiplied by a half minus sine A multiplied by square root of 3 over 2. That's the first expression. And then the second one is plus cos A multiplied by half minus sine A multiplied by square root of 3 over 2. So we're adding the two expressions. So from this, we can see that we have like terms. We have cos of A multiplied by half and also cos of A multiplied by half. And we also have sine of A multiplied by square root of 3 and also minus sine A multiplied by square root of 3. So let me just take you guys back. So for the second expression, this side is a positive. The side is a positive there. You need to remember that. I missed it. So now it's a positive here for the second expression. So that means this sine A multiplied by square root of 3 over 2 and this one, they're going to cancel out because same value and opposite signs. So they're going to cancel out. We're going to get 0 from those two functions. And then here we're going to have half cos A plus half cos A. And then simplifying this, we're going to get something like 2 cos A plus cos A, and that's going to be 2 cos A divided by 2. That's equals to cos A. That's our final answer for this particular example. Now let's do another example. Let me just clear this. Make some space for the second example. Okay, now we're going to be dealing with sine in the second example. We're going to be working with sine, and then we're going to solve that example in the following way. So we have sine A plus 60 degrees plus cos A minus 60 degrees. So we know that we're dealing with sine now. Let's go back to our formulas. I'll try to make space for everything now. Just try to squeeze everything in, and then we can just work on one line. So now with the sine A plus 60, so it's this one, the third formula. So it's going to give us something like sine A multiplied by cos 60, and then with sine, the sign doesn't change, so it's going to be a plus cos A multiplied by sine 60 plus this second function now. That's going to be what? Cos A minus B, which is in the first formula. So we're going to use the first formula. It's going to be cos A multiplied by cos 60 plus sine A. Because it's a positive there, with cos the sign changes to, because the negative, the sign is going to change to positive. So it's cos A cos 60 plus sine A sine 60 degrees. So let's simplify this using special angles. So here it's going to be sine A multiplied by, we know that cos of 60 is equals to a half. So it's going to be a half plus cos A sine of 60 is equals to square root of 3 divided by 2, and then plus cos A cos of 60 is also equals to a half again, and then plus sine A multiplied by square root of 3 over 2, because we're dealing with sine 60 over 2. So now in this case, we're gonna have sine A plus sine of sine A times square root of 3 over 2. So let's work with the like terms, this and that, these are like terms. So from that we're gonna get something like LCM, the lowest common factor will be 2. So it's gonna be 2 and all that, it's gonna be sine A plus square root of 3 sine A. That's how we're going to simplify this 2. And then with this one, it's going to be plus cos A plus square root of 3 multiplied by cos A divided by 2. That's how we're going to simplify this expression. And then from there, this expression can be simplified any further. Let's move on now to exemptions when dealing with compound angles, because these compound angles are not applicable to all problems that you're going to get in trigonometry. For some angles, these compound angles cannot be used. Let me just write exemptions here, and then I'm going to list different angles for which you can use these compound angles. So we can use these compound angles for reduction formula. You cannot be using them for reduction formulas, and also you cannot use them for co-functions. So I'm going to explain this further. Let's say, for example, we have something like sine 90 degrees minus theta. These compound angles or these compound angle formulas cannot be used for that expression. So we're going to have something like cos theta. So we can't use it for sine 90 degrees minus theta. Always remember that, guys. It's very important, because if you make that mistake, you're going to lose big time. So the second one, it's sine 180 degrees plus theta. This is the reduction formula. That is where you're going to use your reduction formula. So you can't be applying these compound angles or these compound angle formulas. This gives us sine theta. This is also discussed in our previous video, where we discussed revision from grade 11, covering reduction formula and negative angles. And then the last one is cos theta minus 180 degrees. This is equals to cos minus 180 plus theta. This is equals to minus cos theta. So you can use compound angle formulas for these three cases. Always remember that. You can be using them for these three cases. Now moving right along, let's look at compound angle proofs now. So that's why we're going to be deriving different formulas for our compound angles. So let me just clear all this space, and then you can make some space for these derivations and just take it from there, because these derivations need quite some space. So now, before deriving these formulas, you need to remember that, or you need to know that any x and y coordinates on the Cartesian plane can be represented in terms of trig ratios. I'm gonna demonstrate that. So, okay, let me just give one example of compound angle formula that you're gonna be working with. Cos A minus B equals to cos A multiplied by cos B plus sine A multiplied by sine B. These are compound angle formula that we're going to be working with. So now let's write, let's draw a Cartesian plane, and then we're going to demonstrate how we can express x and y coordinates using trigonometric ratios. So this is our Cartesian plane there, and then now we have our y-axis and our x-axis. So now let's use this Cartesian plane to, let's first have a line coming from our origin to a certain point P. Let's name this point P. That's where we're going to have an x and y coordinate. And then the length of this line, let's give it a value of r. So that means this line from the origin to the point P has a length of r. And then the angle there from 0 degrees to this line where point P is located, let's give it a value of theta. That's our angle there. So now, going forward, we can use our different trig ratios to demonstrate or to express our x and y coordinates in terms of these ratios. For example, okay, let's just draw this right angle triangle that you can see there, because this point P forms a right angle triangle with the x-axis, and we can draw this right angle triangle for us to be able to explain what I mean by expressing the x and y coordinates in terms of trig ratios. Let's have this triangle here. This triangle is from here, this point. So we just took it from there. It's a snapshot of that. Okay, here we're going to have theta, and then this length will be our r, and then this point will be O, P. And then for us to be able to express the x and y coordinates in terms of trig ratios, we need to know what sides are represented by different ratios. For example, you need to know that sine theta is equals to opposite divided by hypotenuse. And now from this triangle, you can already see your opposite side. The opposite side is here. That's the side that's in line with the y-axis. That's our opposite. And then the side that's in line with the x-axis, that's our adjacent. So we need to know these different sides. And then this r here, that's our hypotenuse. So now, in this case, we're going to have sine theta equals opposite of our hypotenuse. So now the opposite is this length here. Let's just let's just name it y, because it's in line with the y-axis. So it's going to be y. And then the hypotenuse, it's r. We already given that the hypotenuse is r, this length of this line there. So it's r. So now in this case, expressing the y coordinate in this case, we need to make y the subject of the formula in this expression here, or in this equation. So it's going to be y equals to, multiply r by the sine theta. It's going to be r sine theta. That's our y coordinate for this point here. And now to get our x coordinate, we need to work with cos. Cos theta equals to adjacent over hypotenuse. So now in this case, the adjacent is given as the x-axis. So let's just give it value x, because it's on our x-axis. X divided by the hypotenuse, which is r. That's equals to cos theta. So now we need to make this x the subject of the formula. That's going to be x equals to r cos theta. So from these two expressions or these two equations, you can see that x and y coordinates can be expressed in terms of trigonometric ratios. That means this point P, in terms of trig ratios, we start with the fact with the x coordinate is going to be r cos theta, and then the y coordinate is r sine theta. That's our coordinates. That's our coordinates for that point P. So you need to always remember that. And then moving forward now, let's get on right onto it. Let's start with the first proof, where we can prove, or where we're gonna prove that cos A minus B equals to cos A multiplied by cos B plus sine A multiplied by sine B. So I'm gonna draw another diagram now for us to prove that formula. So okay, let me just clear this quickly, and then we can just carry on with our proof. So let's say, sorry about that. Okay, let's say this is the proof number one. Proof number one. That's why we're proving that cos A minus equals to, well, let me just write it down below here because there's limited space on this side. Let's write it here. Prove. You need to prove that cos A minus B equals to cos A multiplied by cos B plus sine A multiplied by sine B. So in order for us to prove that this is indeed equals to that, we need to construct a circle. This circle has to have a radius of 1 unit, and then we're going to use that circle to prove that this indeed is equals to that. Let me just draw the circle here. Okay, on the Cartesian plane again. So it's going to be x and then the y coordinate x. Okay, just like that. And then we're going to construct a small circle because we're trying to save space. This proof is quite long, so we're going to need a lot of space for it. So this point here, this is the point that we used on the previous example that we worked on. So this is our point P. Comes from the center going all the way to that point, and then this angle, let's just give it an B. Let's just name it B, angle B, and then let's draw another line again from the center. This is the center of the circle, represents the center of the circle. That's our origin and the center of the circle also. So let's draw another line from the center of the circle all the way to the circumference. So it's going to be at that point. So we're going to have R there. And then from there, let's name this angle from the 0 degrees to this point, or to the R line. Let's name it angle A. So we also need to mark the points, or to give the coordinates at each point, at point P and point R. We need to give the coordinates for these points. So as we said, the length of R, or the radius of the circle, is equals to 1. Let me just write it here. The radius of the circle is equals to 1. That means this R is equals to 1. That R is equals to 1. So from the previous example that we worked on, we saw that representing x and y coordinates in terms of trigonometric ratios, we're going to get something like R cos theta for the x-axis, or the x coordinate, and then R sine theta for the y coordinate. So in this case, since R is equals to 1, we're going to have something like cos B, because we're looking at this line here and that point there. That means our angle that we're dealing with is angle B. So it's cos B, and then the y coordinate will be sine B. This is because our R equals to 0. So if R had a certain value, a different value, let's say for example, if R was 4, that means we're going to have something like 4 cos beta, 4 sine beta, or sine B, I mean. So in this case, it's just a 1. We don't need to write that 1 there. Our R is equals to 1, so we don't need to write it down. So now moving on to point R, the coordinates for point R, you're going to have cos A, because we're dealing with this angle, not with the bigger angle now. from 0 all the way to this line. So we're going to be dealing with that angle. So our x coordinate will be cos A, and then the y coordinate will be sine A. Those are our coordinates for point R. And then you also need to remember that angle B is less than angle A, because you can see angle B is an acute angle and then angle A is an obtuse angle, so they're of different sizes. So let's move on, and then let's join, let me just write it nicely here. Let's join point P and R. Let's draw a line joining these 2 points up here. So we're going to join those 2 points. So joining these 2 points, we're going to get a triangular shape within this cycle. We're going to have a triangle within the cycle. And let's name this line, or this distance RP, let's name it D. This is our D, the length between these 2 points. That's our D. And yeah, we need to know that the angle in this triangle, or this O there, the angle in this part of the triangle, that angle will be given by A minus B, because it's the angle between these 2 points, between R and P. That angle is equals to A, this entire angle, minus that small angle. We're going to get this part here. So you need to remember that angle there. It's angle, let's call it angle ROP. That's angle ROP will be given by that. So it's A minus B. You also need to note that. So now we're going to have to use the distance formula to calculate the length of D, which is the distance between R and P, point R and point P. So now the distance formula, we're going to have D squared, we're going to have D squared equals to, that's equals to y2 minus y1 squared plus x2 minus x1 squared. So now in this case, we can see that y2, our y2 is our y coordinate, the second one. Let me just write it down here. It's the second one, what's going to be sine A. That's our y coordinate, because we're moving from point P to point R. So the first point is point A, second point is point B, point R. So now all the coordinates at point point P, this is x1, and then this is y1. And then this one, you're going to have x2, y2. That's our second point. So now in this case, y2 is sine A. So it's going to be sine A minus y1 is sine B, minus sine B, all squared, plus x2 is cos A, minus x1 is cos B, all squared. So you need to remember that. And let's remove the brackets now. So now when we remove the brackets, we're going to get sine squared A minus 2 sine A sine B, and then plus sine squared B, plus sine squared B. This is for the first part of our formula. So now I'm gonna, because there's limited space, I'm gonna continue in the second line, or in the following line. Removing the brackets for this part, we're gonna have cos squared A minus 2 cos A multiplied by cos B plus cos squared B. You need to note that these are expressions on 2 different lines. So it's a continuation of this expression all the way to the bottom line. So now from there, you can see that we can apply our trigonometric identities that we learned about in the previous videos. So you can see this sine squared A plus cos squared A. You know that sine squared A plus cos squared A, that's equals to 1. We covered this in our previous videos. So for these two terms, you're going to get a 1. And then we look for some more like terms. We can see this sine squared B plus cos squared B. We also know that that's also equals to 1 from our trigonometric identities. So these two, we're going to have another 1 again. And then we work with what's left now. So it's going to be minus 2 sine A sine B. Let's just cancel them out to show that we have worked with them. And then the second one will be minus 2 cos A multiplied by cos B. So now we're still solving our distance between R and P. That's the length of the line joining point R and point P. We're still solving the value of that distance. So now from here, we're going to have something like 1 plus 1, that's equals to 2, minus 2 sine A sine B minus 2 cos A cos B. And then from there, we can just take the highest common factor from these two. And then that's going to be 2 minus, the highest common factor is 2 here. So we're going to try to factorize this. And then it's going to be 2 into sine A sine B minus cos A cos B. So now from there, we're going to need to name this equation. Let's name it equation 1. So this is our first equation. We're going to have to continue again and derive the second equation and use the two equations to come up with the formula for cos A minus B equals to cos A multiplied by cos B plus sine A multiplied by sine B. So now you guys can pause the video and copy this proof, or this part of the proof, and then we're going to move on to where we're going to use the cosine rule to solve the distance between point R and point P. Let's move on to the cosine rule, where we're going to be solving for the same distance but using a different method. Let's use cosine rule. So with the cosine rule, it's going to be d squared equals to OP, the distance OP from the origin to the point P. So that's going to be OP squared plus the distance between O and R. OR, that's going to be OR squared. And then minus 2, the distance between O and P. So that's OP again, multiplied by the distance between O and R. That's OR. And then multiplied by cos A minus B. This is the cosine rule. For those who have forgotten about the cosine rule, please go back to your grade 11 notes. You can just try to revise, and then it will be a much easier for you guys to understand with the basics of the cosine rule. So let's move on. Remember that we said that the length of the radius for this circle is equals to 1. So the length of this distance OP is equals to 1, and then OR is equals to 1, because all these points, or these 2 points, originate from the origin. So the length of OP, that's equals to 1. We're going to have 1 squared plus OR again, it's also equals to 1, because from the center of the circle, the circumference, it's equals to the radius, also equals to 1. So it's going to be 1 squared minus 2 into 1, and then cos A minus B. Remember that A minus B is this angle here. Remember I talked about ROP. That's the angle that we're working with, because we're working with this triangle here. Let me just draw it nicely for you again here, so that you can try to visualize what I'm talking about. ORP. So now that A minus B, this is the angle there. That's the angle that we're working with. So we're working with these two sides and that angle between the two sides. So we're gonna get something like 1 squared plus 1 squared, that's 2. It's gonna be 2 minus 2 cos A minus B. So that's our second equation for D, or for D squared, using the cosine rule. This is equation number 2. Please write that down, and we're gonna use this equation together with the previous one to solve for D, and also prove that cos A minus B equals to cos A multiplied by cos B plus sin A multiplied by sin B. Now let's move on. Using the cosine rule and also the distance formula, we found two equations for solving the distance between R and P. So now let's say equation number 2, which is the one that you just did now, equals to equation number 1. So we're going to be working with those two equations. So now equation 2 is given by 2 minus 2 cos A minus B. That's the one that you just worked on now. And now this is equals to equation 1, which is 2 minus 2 into sine A multiplied by sine B plus cos A multiplied by cos B. I hope you guys can see, because there's quite a bit of a challenge when it comes to space on the side. So now here we're gonna divide both equations by 2, or both sides of the equation by 2, because you can see that 2 is a common factor in these two equations. So dividing this by 2, you're going to get something like 1 minus 2 cos A minus B. That's equals to, sorry, this is also a 1 there, or you can just write it as 1 minus cos A multiplied by, and then from there you're going to have 1 minus into sine A sine B plus cos A multiplied by cos B. So now you can see that we have positive 1 on the left hand side and positive 1 on the right hand side. So now we can eliminate this 1 by subtracting 1 on both sides. So what we do on the left hand side of the equation, we also need to do it on the right hand side of the equation. So subtracting 1 on both sides, you're going to eliminate this 1. The 1 is going to be cancelled, and then we're going to be left with minus cos A minus B equals to minus sine A sine B plus cos A multiplied by cos B. So now from there, you can see that we have a negative sign on both sides of the equation. So we can also eliminate that negative sign by dividing by negative 1 on both sides of the equation. So this is going to cancel. So we're going to be left with cos A minus B equals to sine A sine B plus cos A multiplied by cos B. So now we've proven that this is indeed equals to cos A multiplied by cos B plus sine A multiplied by sine B. This is the kind of proof that normally comes in your exams. So you need to be familiar with this proof and how we go about it. If you need any more proofs, you can check our website. That's where we're going to load some more proofs with regards to compound angles. We're going to work different examples on the website. You can just check that out. See you on the next video. Thank you guys for joining us.